Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Sana. I'll be one of your hosts this evening, and I'm joined by Parisa. Hi, Parisa.
Hi,
We are
Sana.
current. We are currently broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. The York Universe broadcast runs every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. Universal time or 2 a.m. Universal time, depending on our daylight savings. The York Universe production also works in concert with our online public viewing program run by the Observatory team. It also runs between the hours of 9 to 10 p.m. local Toronto time on our YouTube channel. We have our amazing observatory crew over there right now showing us some archival images from the 1 meter telescope and also talking in the OPV chat about interesting facts about these objects and to answer any questions you might have. If you happen to be listening to this broadcast elsewhere and not on our YouTube channel, please make your way over to yorku.ca/science/observatory and follow the links to our YouTube channel to join the OPV chat. If you have any questions or comments on our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca or get in contact with us on Instagram at the handle @YorkUObservatory or on Facebook at Allan I. Carswell Obs. And as usual, all of our programs are free, but if you would like to make a donation, please see our website at yorku.ca/science/observatory. So usually our OPV chat would include some live imaging with the 1 meter telescope, but unfortunately the weather in Toronto is terrible today. We had lots of rain, thunderstorms, and terribleness earlier today. And the skies are actually pretty clear right now, but we have really high humidity, so can't actually open the dome, even though we have clear skies. So no live imaging tonight, unfortunately. Hopefully we will get some more clear skies on other Monday nights. But Parisa, how are you doing?
Hi, Sana. I'm doing pretty well. Oh my God, Kingston also is very, very humid and pretty, pretty scorching, I say. And I
Hmm.
think it's like all bad in Southern Ontario.
Oh yeah, I was looking at like the radar earlier today, and it was just this huge storm over everything. Um, but
Yeah,
the humidity right now is a killer. Like the temperature is okay, but the humidity is just making everything terrible.
yeah, exactly. We had our open housing. We have once in a month opening our observatory to the public, and we couldn't actually get anything specific because of the humidity and all those seeing stuff. Yeah,
Hmm.
hopefully it's gonna get better next week.
Yeah, fingers crossed. I think we're supposed to get a little bit of clear skies later this week. Knock on wood, we actually get the clear skies later this week after the terrible weather right now. But yeah, maybe for Monday OPV next week we will have some nice clear skies.
Hopefully.
Yeah. Right. Well, we have several things to talk about today, including a lot of JWST. So we'll start off our This Week in Space and Astronomy history with an item that could have also gone in last week because it's not really from the upcoming week. But I just had to talk about it because nobody talked about it last week. And this is one of my favorite This Week in Space and Astronomy history items, which is the second anniversary of the JWST first images release on July 12th, 2021. Now, a bit of background about JWST. This is a 6.5 meter infrared telescope. It sees near infrared and mid infrared light. It's one of NASA's flagship observatories, also has collaborations with the European Space Agency and the Canadian Space Agency. Canada, in particular, contributed an instrument called NIRISS, the Near Infrared Imager and Slitless Spectrograph, which also came paired with the Fine Guidance Sensor, which is what JWST needs to use to point as accurately as it does. So Canada did play a pretty important role in the JWST mission. Now, I think the easiest way to describe Webb is that this is the most like awesome and the most complex space telescope that has ever been created. The 6.5 meter diameter mirror, combined with its massive 70-foot sun shield, which is required to keep the observatory cool, just creates this really, really giant observatory that's the most powerful space telescope that humanity has ever created. And because JWST is so big and so complicated, it actually took 6 months of JWST in space for it to actually be able to start science. Now, Webb launched on December 25th, 2020, which makes it literally a Christmas present to the astronomical community, which is what I always kind of see it as. And then after that launch on December 25th, it had to undergo 6 months of deployments and commissioning. Now, the deployments happened mostly over the first 2 weeks while it was in space, which is just this process that it had to undergo to unfold itself and get ready to start working as an actual functioning observatory. Because Webb is so massive, engineers had to fold it up to put it in a rocket. There was just no way that Webb could have launched in like a science configuration right off the bat, because particularly the sun shield and the primary mirror, the 6.5 meter diameter mirror, was just way too big to fit into a spacecraft. So engineers designed it so that it would sort of fold itself up, fit into a rocket, launch into space, and then unfold itself over the course of about 2 weeks when it actually got into space. Following the initial 2 weeks of deployment, which were the 2 weeks of terror for JWST astronomers, it had to undergo 344 individual points of failure, where if any one of those 344 things didn't work perfectly, the mission would not have been successful, because the observatory just wouldn't have been usable, wouldn't have been able to accomplish its science goals. So really terrifying 2 weeks while it was undergoing those 344 individual points of failure for its deployments. But much to everybody's delight, it succeeded. Everything went very well. There was a little bit of a hiccup while deploying the sun shield, but for the most part, everything was absolutely fantastic. And then after that, it had to go a couple more months before it could start doing science, which was really just doing things like aligning the primary mirror to make sure that it could actually work as a full 6.5 meter diameter mirror, and characterizing the instruments. So taking some calibrations, some test observations, stuff for astronomers to just understand how the instruments worked and be able to use them for science. And after everybody waited these long 6 months from December 25th, 2020, the moment that everybody had been waiting for finally came on July 12th, 2021, when NASA, the European Space Agency, and the Canadian Space Agency finally released the very first set of images and data from JWST. Now, I say July 12th is the first images release, which for the most part is true, but the very first image from JWST was released a day before. NASA didn't really give a lot of advanced warning about this. They sort of just sent a press release out, I think it was a couple days beforehand, like, hey, we're going to release one of the images a day early. And they actually had President Joe Biden do the first images release for NASA. And then all of the other data and images came the next day on July 12th as part of a really massive press conference jointly run between NASA, ESA, and the CSA. So I was super excited about this, and I still remember this images release and how awesome they were. So definitely need to talk about it on this show, because it was really a monumental day in astronomy. Now, starting with the very first image that was released, it was a galaxy cluster called SMACS 0723, which is just a catalog number for this galaxy cluster. SMACS, I believe, stands for the Second Massive Cluster Survey, and 0723 comes from the actual coordinates on the sky that the galaxy cluster has. But more about SMACS 0723. This is a supermassive, or just a massive galaxy cluster that is about 4.2 billion light years away from us. Or if you want to say it in astronomer speak, it's at a redshift of 0.39. So we're seeing this galaxy cluster as it was 4.2 billion light years, 4.2 billion years in the past. Now, I'm sure a lot of people are familiar with many of the galaxy clusters that have been imaged by Hubble, but JWST gave a really entirely new perspective on what these galaxy clusters look like. There are thousands and thousands of galaxies in this image. Many of them are within the actual cluster itself. In those cases, it's able to reveal those galaxies in a way that nobody had ever seen before. So you can see things like the very faint light called intracluster light that surrounds a lot of these massive galaxies in the cluster, something you really can't see with the Hubble Space Telescope or any other telescope, really. It's also able to show us these tightly bound groupings of stars, that very old stars that are sort of smattered around the galaxies in this cluster, which is another thing that you really could never see before in as much detail as with JWST. So it was a really awesome new perspective on the cluster itself. On top of that, there's a whole whack of galaxies in the background of the image, including a whole bunch of galaxies that are among the most distant galaxies that humanity has ever detected. A lot of these galaxies also came along with spectroscopy. So astronomers basically just took the images, identified a couple interesting targets, and then did follow-up observations with a different instrument called NIRSPEC, the Near Infrared Spectrograph, to get spectra of these galaxies, which gives us sort of more information and more detail on them. Once again, just giving a really detailed view of these galaxies that had never been possible before. So absolutely fantastic image to choose for the very first image release from JWST. On top of that, the space agencies decided to release several other pictures and data sets that would basically just showcase the abilities of JWST and help to accomplish its various science goals. So one of Webb's science goals was to observe stellar births and stellar deaths to understand cycles of star formation. One of the images was of the Carina Nebula, which is a massive star-forming region within our galaxy. I'm not going to talk about this one because, Parisa, you're going to talk about it in a minute. So I'm just going to largely skip over the Carina Nebula. But it also released an image of an example of a stellar death of the Southern Ring Nebula. Now, this nebula is what the sun is going to turn into in a few billion years when it explodes. It's just the result of a sun-like star finally running out of the hydrogen fuel in its core and starting to shed its outer layers. There's actually a binary system of stars in the Southern Ring Nebula. One of them is a white dwarf that had already shed its outer layers into space, which creates the actual Ring Nebula itself. And then the other companion star is a star that's currently dying and undergoing that process itself. So it will be shedding its outer layers in, soon in terms of astronomical timescales. And the image itself is really amazing. You can see a whole bunch of detail in the nebula that you could not see before. It also really revealed the second star, the sort of white dwarf in the image very, very well, particularly in the mid-infrared image. You can't really see it too well in the near-infrared image, but that star really just pops out very well, very prominently in the mid-infrared. On top of studying stellar births and deaths, Webb also studies galaxies. This both includes nearby galaxies and very far away galaxies like the ones from SNACS 0723. In terms of the nearby galaxies, it released an image of Stephan's quintet. This is a really cute group of galaxies. There's 4 galaxies that are currently merging and interacting with each other. And then just by chance, there is a 5th galaxy that is much closer to us, sitting right beside them. So it looks like a group of 5 galaxies, but it's really a group of 4. And these images just revealed millions of resolved stars. So you can actually make out one star versus another in these images, and a whole bunch of different star forming regions and pockets of star formation in these galaxies. So it can help to understand in great detail how galaxies merge, how that can influence the stars that's being formed around them and stuff like that. And finally, the last of the JWST first images release was actually a spectra of an exoplanet. Now, this exoplanet is something like a puffy Jupiter planet that is orbiting a different star. It's kind of a weirdo in the sense that we don't have a planet in our solar system that is similar to this puffy Jupiter. It has about half the mass of the planet Jupiter, but is about the same size as Jupiter, so it's much lower density. And it also orbits its host star very, very closely. So it takes only about 3.5 days for this planet to undergo a single orbit around its host star. So it's a pretty unique sort of planet, at least from our perspective in our solar system. Webb was able to take a spectrum of the atmosphere of this exoplanet, and found evidence for water vapor and some clouds and haze in the atmosphere of the exoplanet, which once again is not something that you could do with other telescopes. And I think I've said that exact same thing multiple times now, which is really just to sort of highlight how amazing JWST is. It's really given us a whole new perspective on multiple different areas of astronomy, and is in certain ways rewriting the textbooks on what these exoplanets and galaxies and star forming regions really look like, which is exactly what it was designed to do. Now, since the first images released in the first 2 years of science, there have been tons of awesome, fascinating discoveries. So many that sometimes I forget that JWST science is only like 2 years old. It feels like it's a lot more than that with all of the different things that it's been discovering. Just a couple of highlights of some of the things that Webb has been doing. It's observed several planets in our solar system, so Mars, Jupiter, Saturn, Uranus, and Neptune. It's revealed the rings on some of these outer planets in a great, great detail, which is very hard to do with other telescopes. Webb just has very, very sensitive optics that's able to actually pick up the faint rings on some of these planets. And it's also observed the way that the atmosphere, different layers of the atmospheres of the gas giants can interact with each other and influence what we see towards the surface of, or the cloud tops of these planets. It's also observed rare stages in the star formation process and observed molecules in star forming regions that are important for planet formation, and has observed a whole whack of supernova. It's sort of a supernova machine almost, where it's not only studying supernova remnants in our own galaxy, but it's also able to detect very, very distant supernova explosions. It's broken the record multiple times over for the most distant supernova explosion, and found way more than, I don't think anybody was expecting it to find this many supernova explosions, which is really cool. And then finally, it's done a ton of in-depth studies of nearby galaxies, similar to the ones in Stephan's quintet, and has also been revolutionizing our understanding of what galaxies in the early universe look like. It's been finding some of the most faint galaxies in the early universe and the most distant galaxy ever detected. Only a few 100 million years after the Big Bang, it took incredibly detailed observations of some of these galaxies. So it's really been just rewriting our understanding of the way that certain areas of astronomy work, and is really paying off the $11 billion price tag that came along with this telescope. So this is, happy anniversary to the second year of JWST science, and I definitely can't wait to see what the future years hold.
Thank you, Sana, for such an amazing summary of what we got from JWST. So, as Sana mentioned, there's a lot of science going on, and one of those, I just picked one of those very first images that it released by JWST. Sorry, I was a little bit selfish because I'm working on the planet and star formation, basically star formation. So I picked Carina Nebula. Um, so I think in this case, because I think all of you might have already seen those stunning images from JWST, and especially not only the picture from the JWST from the Carina Nebula, but also the comparison with what Spitzer Space Telescope and also Hubble Telescope was seeing before. All right, Sana, like it was a huge difference.
Yeah. Yeah, I remember a couple of days after the image release, there was this meme that I saw online of like, somebody like takes off their glasses and you see something completely different. And somebody had put the Hubble Carina Nebula image next to the James Webb image in that meme, where it's like the Hubble Carina Nebula image is when you take off your glasses and you put them on and you see the Webb Carina Nebula. But I mean, regardless, I think the Carina Nebula is one of my favorite nebulae from JWST.
Exactly. So basically, JWST has a resolution like about 20 times better than Spitzer in mid-infrared, because the Spitzer Space Telescope was also designed to capture the stuff in the infrared, and also 2.5 times better than Hubble. But like we all know, Hubble is doing a better job at visible lights because it's an optical telescope. But on the other hand, in the infrared images, JWST is doing 2.5 times better resolution than Hubble. But I'm always like using that analogy that we think we always like talk about JWST is doing a better job, or like revealing those embedded objects which are deeply behind or hidden behind all those dense gas and dust, and how actually this telescope works. Because imagine if we're like, you and a bunch of your friends sitting in a dark room, and then suddenly I'm picking my camera to take a picture. So basically, we cannot detect anything because our camera is designed for the optical wavelength, right? But on the other hand, if I have a visible, basically visible night visible camera, which is infrared camera, then I can capture like the individual bodies in the room. So that is exactly happening with the JWST, because all those objects out there having a non-zero temperature. So what a JWST is doing is going to the like larger wavelengths, which is actually we detect the longer wavelength electromagnetic field, like which is electromagnetic radiation, which we call them infrared. But with the Carina Nebula, which is very fascinating about that region, that we could see all those stuff that we couldn't see with the Hubble, and it revealed a lot of details that it was absolutely impossible with any other of those telescope that we already had. And we could see a lot of things that actually astronomers didn't know what they are. A lot of cliffs, a lot of filaments, much more details that we had actually no clue that they are even existed. And that was actually one of those things that it was absolutely mind blowing. But a little bit more details about that particular nebula, that this is a part of the NGC 3324 star formation region, which is one of those most active star formation region which is already existed. And what it's there's a lot of studies going on with those nebula that the JWST resolved. And there was a recent paper which was from Brianna Krumfutz. She's a PhD student actually at the Victoria University. And her master thesis was on that Carina Nebula. And their paper came out just a few months ago, and they identified 19,497 objects, which was incredibly and in 450 of them were about to be baby stars, which are like the in astronomy we call them YSOs, or young stellar objects. That 450 of those objects supposed to be a star with a high probability in their analysis. And 427 of them, so of those objects, were new discoveries which was not previously identified by Spitzer. So I think in this case, we know that by how much JWST is doing a much better job at the identifying young stellar objects, and it was incredible. I don't know, Sana, did you know that there's 427 new objects which are baby stars in Carina Nebula?
No, I didn't know that.
Yeah, that's very, very impressive, because like why we care about these numbers actually, because despite the fact that we know quite pretty decently that how stars form, or what is the evolution of the stars, we actually do not know the very, very precisely, and it's the very open question in astronomy, that but like what is the initial conditions in the molecular cloud which ended up to form a new star. And it is still a big question because we have a lot of things going on in nebulae, like including Carina nebulae in this case. For example, I don't know, a stellar wind, magnetic field, a lot of other things which suppress the star formation. And actually, that makes the star formation a very, very inefficient process. And if I tell you that for a typical molecule cloud, actually the star formation efficiency is more or less 1%. And that is crazy because if you think about all those materials which existed out there, only a few percent of all those material existent in a molecule cloud ended up being star. And for example, for our Milky Way, I'm just want to give you like the content to figure out how low it is. Like for our Milky Way, the star formation efficiency is actually like that the Milky Way only produces 2 sun-like star per year. And which is I don't know, like Milky Way has like a billion and billion number of stars and only 2 sun per year. I don't think it's like a lot of star compared to what we see out there. So for that Carina nebula, that recent paper actually just they in their discussion they were talking about that the star formation efficiency in that region might be larger than a typical molecular cloud, which we know like it's more and less it's 1%. But as we go like closer and closer to all those regions which are gas and dust are so much more, it can sometimes the star formation efficiency can reach up to 30% sometimes in those dense cores of the molecular clouds. So which means there's always when we got a new telescope and we looking at the the stuff out there, not only we cannot really answer questions for sure, but also it also opens a lot of more open questions as well, right? Because I don't know, never and science never ends, right?
Oh yeah. A very similar thing has happened with the galaxies side of things on JWST. I I'm a galaxies person, so I don't really know what's too much about what's going on with the big open questions and exoplanets. But the exact same thing happened with galaxies. People just started finding these galaxies that everyone is sort of scratching their head and going, "How do you get that?" at
Exactly.
in the early universe. And even now, like 2 years into JWST science, there's still more questions being created and so many more opportunities for further observations to try and solve some of these mysteries.
Exactly. So once we know better even about how the stars form, it also opened the door for us to figure out how planets form because it's more or less the same process like the planets in the disk of those like mother star. So it's very interesting that even for a very small scales also, like you working with the galaxies, I work in a very small cores, which are, I don't know, literally 100 times smaller than it's I don't know like I don't know even a molecular cloud. But so we still do not know how these objects form. So not only people and researchers are working on the other regions to looking at it with the JWST to see if they figure out the same results or no, and if yes, maybe it can change our perspective about the percentage of the materials are ended up being star.
Yeah, that is really fascinating. That's also uh, an interesting question in and of itself with local, I guess, star forming regions, but very true also for star forming regions of distant galaxies too. Um,
Exactly. That is one of the reasons that we need to focus more on those galactic star formation regions because we cannot really resolve all those very, molecular clouds in a like extra galactic region. So the more, the like actually the better we can model what's happening in our galaxy, it can just give us a lot of clue about, much more distant galaxies and characterize them.
mhm. Yeah, it's also interesting to see the variation in conditions that you can have in these different regions. Because one of the things that extragalactic astronomers do a lot is you have to apply a certain assumptions to measure properties of galaxies. And there tends to be this assumption that you apply things that you learn, one thing that you learn, you apply that to distant objects and don't always take into account that conditions might not be the same. So it's really interesting to see the different variations of, 1% star formation efficiency versus potentially 30, and how that can influence things like properties of or properties that we measure of these galaxies. So yeah, whole bunch of
Yeah,
interesting science.
there's still a lot of things to go on.
Oh yeah, yeah. And before we stop talking about JWST, I also want to mention that NASA does an image release every single year on the anniversary of JWST science. Last year, we got the fantastic Rho Fucci image from Webb. Parisa, have you seen it?
Not really. I should check it
Oh
out.
God, it is gorgeous. This has got to be one of like my favorite Webb images. Carina Nebula is gorgeous. I love it. I also love this one because it's just so beautiful. Um, but this year we got a kind of funny galaxy, the penguin and the egg, which is a pair of nearby galaxies that are merging. And it actually looks like a penguin with an egg sitting there, just because of the weird gravitational interactions happening between these two galaxies. It's sort of warped one, so it looks like it's kind of bent over almost. And yeah, looks like a penguin and an egg. It's really cute. Um,
It's
but
really funny because we can just expand our imagination when we're looking at the sky because when we're looking at the cloud we can just see a lot of funny images that we think about as like literally like galaxies that human beings try to like associate it with the things that we know on Earth, and it's funny.
mhm. Yeah, there's also, I don't know if this is a JWST image, but there's this gravitational lens that actually looks like a smiley face.
I didn't
It's pretty
see
funny.
that. Oh my God.
Yeah, I don't think it's a JWST image, but it literally looks like a smiley face in space, which is just hilarious. Yeah. All right. Well, I think I know I could talk about JWST for a really, really long time, but we are at sort of the midway point, so we should probably move on to the last This Week in Space and Astronomy history before we get to some of the news items. This is sort of a couple of different This Week in History items in one, all as a part of the Apollo 11 mission. This has to be one of the most well-known or well-recognized missions to space ever, because it's the first time that humans have actually walked on the moon. This was a goal that was set out by the American President Kennedy in 1961 during the space race with the Soviet Union, with the goal to send humans to the moon, have them walk on the lunar surface, and then return them to Earth safely. And that is exactly what the Apollo 11 mission accomplished. It's part of a series of the Apollo missions, which before Apollo 11 mainly dealt with testing various aspects of spacecraft. A lot of them were crewed missions, two of them were Earth orbiting missions, and then two of them were actually missions to the moon, where the spacecraft would sort of do a little loop around the moon or orbit the moon a little bit and then return to the Earth quickly, just to sort of demonstrate that it is possible to send humans to the moon and do a dress rehearsal for the Apollo 11 mission. And then all that eventually led up to July 1969, when three astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins, went to the moon with the purpose of actually walking on the moon for the first time. The way the crewed Apollo missions that landed on the moon worked was that there were two components to the spacecraft: a command module, which was nicknamed Columbia for convenience in the case of Apollo 11, which is the capsule that astronauts would launch in, would live in while they were in lunar orbit and on the way to and from the moon, and would also be the capsule that they returned to Earth and splashed down in the ocean. And then there was also the component of the lunar module, which was nicknamed Eagle for Apollo 11, which was the actual part of the spacecraft that would land astronauts on the surface of the moon. What would happen is that Michael Collins would stay in orbit around the moon by himself for multiple hours by himself orbiting the moon in the command module Columbia, while Neil Armstrong and Buzz Aldrin would actually go into the lunar module, detach from the command module, land on the surface, walk on the surface for a little bit, and then reattach with the command module a little bit later. So Michael Collins was definitely a little bit lonely during this time by himself in the command module, but it did ultimately lead to the first successful mission of humans walking on the moon. The two different dates that play into this is July 16th, 1969, which was when the crew actually launched. They launched from the Kennedy Space Center aboard a Saturn V rocket, which I think even to this day remains the most powerful rocket that has ever taken humans into space. And then the actual landing on the surface of the moon happened on July 20th, 1969, which accomplished President Kennedy's goal from several years earlier. Now, the astronauts landed in an area of the moon called the Sea of Tranquility, or Mare Tranquillitatis. This is an area of the moon that is known as the mare. So it's essentially just this really old surface of the moon, or actually it's kind of young in lunar terms, so ignore that. It's one of the younger surfaces of the moon that got filled in by ancient lava flows on the moon over very long periods of time. These lava flows cooled to create these pretty smooth surfaces on the moon that tend not to have a lot of craters, which is why we know they're younger, because they're less cratered than some of the other areas on the surface of the moon, like the South Pole. These seas create really the perfect landing location on the surface of the moon, because there's nothing you can really run into when you're trying to land there. You don't have a lot of complicated craters or complicated geology that you can crash into and mess up your spacecraft. So this was the site, the Sea of Tranquility, that was chosen for the very first landing, just because it was the easiest spot. You want to build in complexity on these missions. Start off as easy as you can, and then once you learn from these missions, start to do more and more complicated things, which is exactly what Apollo 11 did. They landed on the Sea of Tranquility at 4:17 p.m. EDT, and then a few hours later at 10:56 p.m. EDT on July 20th, Neil Armstrong became the first person to step foot on the moon. When he did that, he said the famous quote, "That's one small step for a man, one giant leap for mankind." And an interesting thing about this quote is that a lot of people skip the A in the quote. So they'll say something like, "That's one small step for man, one giant leap for mankind." Because when you listen to the recording, it's kind of hard to hear the A in that sentence. But when Neil Armstrong was asked about it after the fact, he said that it was supposed to be one small step for a man, which is why everybody says in the quote that is one small step for a man instead of one small step for a man, as if you would hear if you were listening to the recording. Not long after Neil Armstrong became the first person to walk on the moon, Buzz Aldrin joined him a little bit later on, where he described the surface of the moon as magnificent desolation, which just by seeing pictures, I would tend to agree. It's gorgeous, some of these pictures, but is definitely a desolate place. No life on the moon. So it's definitely kind of looks a little bit like a cold and lonely place. But all of these Apollo missions have really revealed the moon to be a fascinating place. So focusing more on the things that the Apollo 11 astronauts did, they had an extravehicular activity, or a spacewalk, that lasted for about 2.5 hours. They took a whole bunch of pictures on the moon. They planted the American flag on the moon, which was essentially winning the space race in that case, and also collected a whole bunch of different rock samples to bring back to Earth for analysis. And we were really able to learn more about where the moon came from a lot of these rock analysis, and learn more about lunar geology in general, even just from the first Apollo 11 mission, but also from a lot of the later Apollo missions as well. They also left behind a little plaque, which is a tribute to the Apollo 1 crew, who had died in a fire on the launch pad several years earlier. So just a little sort of thing to commemorate that crew and sort of honor their contribution to spaceflight. But overall, the mission was a massive success. They had a little bit of trouble when they were actually starting to land because the area they were landing in had an unexpected amount of boulders. So Neil Armstrong actually had to take manual control of the lunar module to sort of fly over this boulder field to a smoother part of the moon where they could land. But it was really a resounding success. The astronauts returned home safely a few days later on July 24th and accomplished all of the mission objectives for Apollo 11 and also paved the way for future Apollo missions all the way through, I think it was to Apollo 16. I think it was Apollo 16, where astronauts started to do more and more complicated activities on the lunar surface. So things like landing in more complex areas that were of scientific interest, taking longer spacewalks, including using these moon buggies, so kind of cars that they would drive around on the moon to increase how far they could go and how far they could explore in the lunar surface. So yeah, great start to a fantastic set of crewed Apollo missions to the moon where astronauts would actually walk on the moon.
Exactly. I don't know, like we're about to go to the moon again in 2026 that they said. I don't know.
Uh,
Oh, I
maybe.
don't know. I don't know if it's that going
Yeah.
to be early, but like one of those, very, I don't know, just conspiracy theories was just like, we've never been to the moon because why we're not going that again. And I'm like, they're planning anytime soon, so don't worry about it. But yeah,
Hmm.
that was, yeah. So looking forward maybe to have a very, very first woman walking on the moon, hopefully next time.
Hmm. Yeah, the awesome thing, or the thing I was super surprised about for the upcoming Artemis missions is that the first Artemis mission, which is not going to actually land humans on the moon again, it's just going to be in orbit around the moon for a little bit, is that it's going to be the first Canadian to go into orbit around the moon. There's three NASA astronauts and one Canadian Space Agency astronaut. Artemis is unlike the Apollo missions, which were purely an American thing. The Artemis missions are going to include a lot of international partners, which includes Canada. And I knew Canada was going to get a seat on some space missions to the moon, but it's really awesome to me that it's going to be the first crewed Artemis mission. And Canada will then be the second nation, only after the United States, to send humans to the moon, even if they're not walking on it, which I think is pretty awesome.
No, it is absolutely awesome. It's very awesome because like it's not a really simple mission to just, risk everybody's life to just take a risk and just aim for going to the moon again. We need to just check a lot of other things before taking other steps. But yeah, and I think that is amazing that we have other nationalities and it's going to be very more international because space is a place which is belongs to everybody. Um,
Mm-hmm.
and it's not really explicit to a specific country, but that is amazing.
Yeah, exactly. It's that's kind of one of my favorite things about a lot of the more recent missions is many of these missions, even JWST, they're led by NASA, but they have so many international partners, which I think is an awesome thing. Um, Definitely agree. Space is for everyone.
Yeah, absolutely.
All
So do
right.
you want to move to the news, maybe?
Yes. So, for just very briefly, for those of you who are just tuning in, you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Parisa and I have been currently discussing Apollo 11 and JWST and have a bunch of or two super interesting news items to come up. But just a very brief reminder for anybody who is looking to visit the observatory in person, we are typically open every Wednesday. However, this week we will not be having an in-person tour. Our next tour coming up is on July 24th from 9 to 10:30 p.m. on the atrium, and we will be going back to tours most Wednesdays after that. The all of these tours are free, as are all of our programs and all of our events. But we do ask that you sign up ahead of time just so we know how many people are going to be there and we don't overload the observatory with a ton of people at once. So if you would like to come visit us in person, please do. We'd love to have you. But sign up ahead of time on Zephy. You can go get tickets, which are again free from yorku.ca/science/observatory, and there'll be links on the front page to get the tickets. But yes, we do need to move to news items because we are past the midway point of, and need to get to news. And Parisa, you have a really cool news item for us to come up.
Yeah, it was something interesting that actually last Thursday on July 6th, that at precisely 4 p.m. Eastern time, like what we have right now, I mean in the eastern part. So we reached the furthest point from the sun in our orbit. And that might surprise you because I mean, for those one who do not know that like we are in the middle of the summer and it's very hot. So maybe that doesn't make sense that we're in the furthest point of our location from the sun. But it's actually it really doesn't matter the change in the seasonal weather, and then the temperature has nothing to do with our distance between Earth to Sun, and it's more about a tiltation of the Earth around its axis. But specifically at July 6th, last Thursday, we were at the point that we call it aphelion. And in that point, the sun is about 94 million 506,364 miles, or approximately 152 million kilometers away from us, and which is this like large distance is about 5 million kilometer further than when we were actually closest to the sun, on the very beginning of the January, which we are at the beginning of the winter. So it's actually totally opposite. But when we were at the like the coldest time, we were the closest point to the sun, and when we were like the hottest time, we're actually the furthest. And that is very much just because the tiltation of the Earth around like by its axis. And it's on our like in a southern Ontario, in our latitude, because the sun rays are much more direct on about June 21st, which we call them summer solstice. And when the sun is like the sunlight is very direct, it brings about 3 times as much heat compared to more slanted rays of the winter solstice on around December 21st. And that's why we have such a noticeable temperature difference between summer and winter. So just to break it down, the summer solstice is when the day is the longest and in the year, and then the sun is at its highest point in the sky. And also the sun rays hit the earth more directly, and resulting in a longer daylight hours and warmer temperature. On the other hand, the winter solstice, it's the shortest day of the year, around December 21st, that the sun is at the lowest point in the sky at noon, and the sun rays are more slanted, leading to a shorter daylight hours and cooler temperature. So I remember that oh my god, in my elementary school, I had a teacher that she was describing to us that the reason of the hotter temperature is because we're closer to the sun. And I'm like, I'm just gonna, if she hears me, and I'm like, you were wrong, and this is just only because of the angle of the Earth around its axis. So that was pretty funny. So if you're a teacher and you want to like teach kids why we're experiencing such a hot temperature right now, it's not because of that distance.
Yeah,
Uh,
I gotta say that was one of the things I was surprised to learn.
exactly, because it makes much more sense to our physical imagination to like, okay, like the furthest we are, maybe the colder it gets, but actually it depends like in what direction we got those sun rays like on Earth. So which is right now we experiencing the summer in the northern hemisphere, and it's totally opposite in the southern hemisphere, and they experiencing the winter. But it's funny because those dates of like when we have those like the longest distance and when we have the shorter distance from the sun vary a little bit due to several factors related to the Earth orbit and gravitational influence of other celestial bodies. So, for example, we can say the shortest distance is about January 1st to 5th, And then the longest distance is about July 2nd to 6th. And that little bit of variation was because the Earth orbit around the sun is not perfect circle, but it's an ellipse. And that shape of this ellipse changed slightly over time due to gravitational interactions with other planets, especially Jupiter and Saturn. And these changes in the orbit shape, known as orbital eccentricity, and that can cause the timing of those longest and shortest distance to shift a little bit. And also the gravitational forces from sun, moon, and other planet also cause a low wobble in Earth's rotation axis. And this wobble called the precession of the equinox. And this gradually shifts the orientation of the Earth's orbit over the time. And over a long period, this precision can alter the timing of when Earth reach the longest or shortest distance from the sun. So we have a lot of things going on. We cannot never predict like very precisely when is the date. I mean, we can a year before, but like over a very, very long time, these shapes of the orbits change.
Yeah, it's pretty remarkable how planets that are very far away from us can actually have that much of an influence on the Earth. I know it makes sense just understanding how gravity works and everything, but that was one of the other things that I was a little surprised. Like, wow, Jupiter
Exactly. So, for
can
example, when we're
actually
dealing with the actual numbers, that's very surprising because, the distance between Earth to Sun right now is about 152 million kilometers, and we're still like, the still those planets affects us gravitationally to change the shape of the orbit, and that's really fascinating. I think when we're thinking about astronomical units and number, it's just mind blowing. I gave up actually, honestly, to imagine.
oh yeah. Yeah, like distances in astronomy stop making sense real fast.
Exactly. So, Sana, do you want to tell us more about your news?
Yeah. All right. So, more, or I guess another update on what the sun has been up to recently. We are currently approaching a solar maximum, which will take place between either now, so late 2024 or early 2026, which is really just kind of what it sounds like. It's a period of a very high activity on the sun. All of this activity is driven by the magnetic field of the sun doing things like flinging material and high energy light out into space. So things like solar flares, coronal mass ejections, and also various sunspots on the surface of the sun, which are just areas that are colder than the surrounding area. So look like these little spots on the surface of the sun. They might look small in the image, but keep in mind these things are massive. Like a lot of them are a lot bigger than the Earth. So this is pretty extreme activity that's being caused by the sun's magnetic field. And for some reason, every 11 years, the poles of the sun flip. So right now we're approaching the time where the poles are going to flip, which is leading to an increased amount of activity on the surface of the sun. And after another 11 years after this, the poles will flip again and sort of be in their original position. But because we're approaching the solar maximum, there's been a whole whack of things happening at the sun. It's been flinging material at us like crazy at the moment, which has caused a few interesting things to happen on the Earth, including a bunch of awesome and very powerful aurora. So, Carissa, did you see the aurora from more
No,
recently?
I'm actually, to be honest, like I didn't go with my friends because I was very pessimistic, but they saw it, and I was just like, so shocked
Oh,
I missed it. But yeah, like on that night, I think it was almost 2 months ago, like months ago, that we had
mhm.
it in Kingston, which was like very surprising because Kingston's like relatively low on latitude. So yeah, it's very strong.
Yeah. I also did not get the chance to see the aurora. It was a little bit too cloudy where I was at the time, so you couldn't really see anything. But because we're at a solar maximum, we might get another chance at them maybe one or two more of these very strong events might happen over the next couple years. So fingers crossed. But most recently, what the sun did on July 12th at 10:34 p.m. was it had an X-class solar flare, which is the strongest solar flare you can get. It's just these really, really intense bursts of high energy radiation, in particular X-rays and extreme UV radiation. So just for reference, there's multiple different classes of solar flares that you can have. X class, again, is the strongest, but there's also M, C, B, and A class flares, which are just less intense, bursts of radiation coming off of the sun. But this particular X class solar flare hit the Earth. It was just directed right at us and actually caused a little bit of problems for people who use shortwave radios in Australia, Southeast Asia, and Japan. When these solar flares reach the Earth, this is very high energy light, so it can actually ionize the Earth's atmosphere or parts of the Earth's atmosphere, which just make it very hard for radio waves to actually be able to propagate through the Earth's atmosphere, which results in shortwave radio blackouts during these time periods. Unfortunately, this solar flare was not associated with a coronal mass ejection, which is what you need to get aurora. Very similar to the X-class solar flares, the coronal mass ejections are just, radiation and charged particles from the sun that can interact with our atmosphere in a kind of similar way and cause the atmosphere to kind of glow in colors, mainly green, but a little bit of purple in there as well. So we didn't get those really pretty aurorae this time around, just the X-class solar flare sort of messing with the shortwave radio people in certain parts of the world. So I'm really hoping to get another one of these coronal mass ejections that actually causes aurora. We don't want one that's too strong because that can actually cause some serious problems for a lot of people. Just thinking back to the Carrington event very, very long time ago, where the sun released a really, really powerful coronal mass ejection, and it actually wiped out some, I think it was transponders at the time. So if we were to get hit with a Carrington event level solar flare, which the sun has ejected in this solar cycle, just it wasn't directed at Earth, thankfully, it could actually do things like, destroy our electrical grid. So hopefully we don't get a coronal mass ejection that's that strong, but I'm really hoping for more of these strong aurora. And anybody who is actually looking to track the aurora, there are certain apps that will notify you if there's a high probability of strong aurora in your area. And various government agencies in the United States also have these periodic updates on sort of space weather and any of these conditions. A good one is the National Oceanic and Atmospheric Administration, or NOAA. If you just go to their website, they will tell you what the current, the latest observed space weather conditions are from the sun and what the predicted space weather conditions are for the next few days. So if we are about to get hit with another one of these sort of I don't know if solar storm is the right word, but if we are going to get some strong aurora from the sun flinging material at us at very high speeds, you will probably have a little bit of warning and can plan to go observe that. So that's definitely on my list, is checking that website and planning to look for more aurora.
Yeah, exactly. I'm not sure if we can see the color from our latitude because like previous time, due to my other friends like just reported they couldn't see the colors, but they were like strong enough that they could see the change in the atmosphere. So they saw the shed, but yeah, not any colorful, beautiful, like those spectrum of colors. But hopefully, I don't know. One of
Yeah.
those funny things that when I was at the Killarney Park doing a like astronomer in residence, there was only one night that I slept and not doing astrophotography, and that specific night the aurora happened, and I'm like, oh my God,
Oh my God.
just a shame.
Oh, you have the worst luck. Oh my God.
Yes, exactly. Unfortunately, but hopefully this time.
Yeah, yeah. Just got to keep checking those those forecasts, and hopefully we'll catch one with good weather, fingers crossed.
Yeah, hopefully.
But yeah, that brings us to the end of the hour. Everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Parisa and myself, Sana. You can always connect with us on Instagram with the handle at YorkU Observatory and on Facebook at Allan I. Carswell OBS. You can also check out our website, yorku.ca/science/observatory, for show notes, content, updates, and contact info. Thanks for tuning in to York Universe. Clear skies and have a good night.
Bye, everyone.